Hi, in this lesson, we'll look at 2D vectors. Let's get started. In this lesson, we are going to extend our knowledge of vectors into 2D vectors. The 2D vectors provide a grid-like data structure that can extend our programming capabilities. It is essentially a vector of vectors. A 2D vector is essentially a vector of vectors. Creating a 2D vector, therefore, is similar to creating a standard vector, with the exception that the vector type is a vector itself. In the example above, notice the space between the two closing angled brackets, as seen right here. Remember that two angled brackets together are used for streaming, such as printing lines to the console. So to distinguish the closing brackets from a streaming operator, you must leave a space between the two closing brackets. Just like a single vector, you can create a 2D vector with default values. As a vector of vectors, you define the default values with a set of curly brackets, comma separated. Similar to how you access a single vector, a 2D vector is accessed by stacking two sets of square brackets. The first bracket accesses the row, and the second bracket accesses the column. As always, the index values of the vector start at 0 and go to 1 less than the length of the vector. For the example in the previous slide, to print the 3 in the third column of the first row, you would access it like this. You have two sets of brackets. One is 0 for the first row, and 2 is for the third column. To update the value, you can assign the value directly. As you can see right here, this would change the 3 to 8. You can access all the values with a nested loop and the size function for vectors. As you can see, we use a nested loop, and we use the size function. Just like with a vector, you can use the pushback function to add to a 2D vector. As you can see below, this will add to the first row, and this will add to the second row. Now, let's take a look at an example. In this example, you can see that we put a space between these two. This is because we use angled brackets for printing, as shown here, so we don't want the computer to get confused. This will push back a 4 and an 8 onto the first and the second row. And here we get our result. We access all of the things in our grid. As you can see, we have our updated grid right here. You can create a 2D vector using default values with nested curly brackets. However, while this option may work for small grids, an automated process is critical for creating larger grids. To do this, we use loops. However, the structure of a vector is not fully developed when it is declared. Declaring a 2D vector does not provide a place to update values that have not been pushed back into the vector structure. In the example below, the code will fail since the word grid does not yet have a row 8 or a column 6. To remedy this, if you want to create a filled grid, you would need to loop through and add rows and columns to initialize the grid. To do this, you first create a row by pushing back all the default column values. Then you push the row back to the main grid. Let's look at an example where you create an empty 10 by 10 string grid. After running the nested loop above, you will be left with an empty structure that can be updated using square brackets to access values. As you can see now, we will be able to successfully update the value to hello. Let's look at an example. As you can see right here, we are making a 10 by 10 grid. Now we are able to successfully make a grid, as you can see right here. Now that you learned about 2D vectors, let's get some practice using it in the CodeHS editor.